So now let's see how to solve the first order linear differential equations. And given the form, the linear equation form, which is y prime plus p y equals q, and we know that the coefficients for the linear first order ODE will be only as function of x or constant. So we can rewrite these equations to be a standard ODE, such as mx y dx equals y nxy dy equals 0. So let's rewrite into a standard form, which is py minus q dx plus dy equals 0. And you know this is dy over dx plus py equals q, right? So you just times dx and then change all the form of dx into one term, dy into one term equals to 0, okay? And then we know this part is the n will be equals to 1, right? So it's m dx plus n dy equals 0, m equals py minus q, the n equals 1, okay? And then let's check whether it can be separate, right? And it couldn't be separate, Then let's see whether it can be homogeneous. And you know, it has to be depending on this py minus q term, this n equals 1, whether they have the same power. Probably won't be the same power. So let's check whether it's exact or not. So check exact. Since how to check the exact? So you have dm over dy, whether that is equals to dn over dx. And you know that dn over dx will be equals to 0 because n equals to 1. So that is 0. The dm over dy will be equals to p, clearly. And you know that this p is a function of x or a constant, so that this part won't be equal. So they are not exact. And then if this is now exact, can we use the integral factor gx to make such equation to be exact? So the second part, we are trying to get the integral factor gx. So it's 1 over g dg over dx equals 1 over n dm over dy minus dn over dx. Okay, and you know n is equals to 1, so dn over dx will be equals to 0, 1 over n will be 1. dm over dy will be equals to px, and that is. So now you can see that this seems to be a separable form of ODE. So we just put all the g part on the left, all the n part on the right, x part on the right. So dg over dx, dg over g will be equals to px dx. Okay, and if this is the separable form, you can just integrate both parts to get the gx. So what we do is integral both parts, which is ln g will be equals to the integral px dx. And then the g will be the exponential of px dx. Okay? So we get our integral factor. So with this integral factor, such equations will become exact equations. Okay? With the integral factor gx equals e to the px dx. The first order linear ODE y prime plus py equals q become exact. And of course, you can check the exactness by your own side and verify with this integral factor, such equations become exact. Okay. Okay. So we can rewrite these equations with the integral factor gx, which is e to the px dx y prime plus e to the px dx py equals e to the px dx q. Okay, so after the integral factor gx, you can rewrite this first order linear ODE. And since the d over dx e to the px dx y, when you do the differential, that is differential each term, right? So it will be e px dx dy over dx plus the y part times the e to the px dx over dx. So that is the integral part. And this can be write as e to the power px dx y prime. Dy over dx is y prime. And plus the d of this total part will be e to the px dx y times the integral power part px dx over dx. And so this is the integral of px dx, and you differentiate with the dx will be equals to the px only. So these equations will be equals to px dx y prime plus e to the px dx times y times px. Okay? And if you see this equation, this exponential part times y prime and plus this exponential part times y times px, that is equals to the right, which is px dx q, right? Okay. Okay. So after that, we know that this left-hand side will be equals to the right-hand side. Then we can do the integral from both sides, which is e to the px dx times y. That will be equals to the integral of the right-hand side, which is e to the px dx times q dx, right? The integral. And plus some constant. And after that, you can get what is uy. Y will be equals to e to the minus px dx. You just put this side to the right. And then times the integral e to the px dx q dx plus some constant. Okay, so this is the form how to get this y, and you can see that this y is separate. So this y is using the expression of this as function of x, and such solutions for the y is called explicit solution. Okay, so usually we can get the explicit solution for y using such term, okay? So that is how we solve the first order linear ODE, okay?